My name is Dr.R.KANNAN, Associate Professor in EEE Department of Erode Sengunthar Engineering College, Erode. So today I am going to discuss about the closed loop operation of DC drives. So what is meant by closed loop operation? Why we require this closed loop operation for the DC drives? Okay. So first one, the closed loop operation is required to improve some factors. So what are the factors? Okay. The first one, to improve the steady state accuracy of the system. The second factor need to go for the closed loop operation is to improve the speed response, improve the speed response of the system. Speed response. And third one is the important for this drive is called as to protect. That is, a protection is required. So therefore, to protect the entire drive systems. So these are the three important factors is required to go for the closed loop operation. Okay. So what is the purpose of the closed loop operation in the DC drives means? In our latest industrials, we have a automation of the process for the number of applications. Okay, so we need to control over the speed of the DC drive. We require the closed loop operation. So this can be achieved by two different methods. Okay, now what are the methods available to obtain the closed loop operation of the DC drives? We will discuss now. Okay, so method of closed loop operation. Method of closed loop operation. Method of closed loop. The first one is called as current limit control. First method is called as a current limit control. Second method is called as inner current control method. These are the two important methods. By this nature, we can obtain the closed loop operation of the DC drives. So the basic concept of this closed loop operation of the DC drive is nothing but to control the speed of the DC motor. So what are the methods we have controlling the speed of the DC motor? Mainly we have here armature control and the field weakening control. This already we know. Okay, there is a famous two methods to control the DC motor. One is called as the armature control. What is meant by armature control? That is, armature voltage control is nothing but with respect to the field current is a maximum. That means we need to maintain the field current as a constant. During that time, if you vary the armature voltage applied across the armature of the DC motor, then the speed can be controlled. So that is called the armature voltage control. Then the second method is called as field weakening control, or otherwise we can call it simply field control method. What is the field control method means? We need to vary the field current by maintaining the armature voltage as a constant. Okay, such that we can obtain the control over the speed of the DC motor. Then what is the difference between armature voltage control and the field weakening control? So this is based on the speed values. If you want to control the speed below rated speed, then we have to go for the armature voltage control. That is, that speed of the DC motor can be controlled from 0 to rated value means we have to go for the armature voltage control. Then if you want to control the speed above the rated speed, then we have to go for the field weakening method. Okay, so these are the two important methods to control the speed of the DC motor. So that methods we are going to implement in the closed loop operation. Okay, how we are going to implement the armature voltage control or either field weakening control in a closed loop operation such that how we are obtaining the speed control over the DC drives. Okay, so that is we are going to discuss with respect to the two variable closed loop operations. Okay, so first one is a current limit control, then second one is called as the inner current loop control or simply inner current control. Okay, clear? Okay, so first we are going to discuss about the current limit control. Okay. Okay, now we are going to discuss about the first method. First one is called as current limit control. Current limit control. So what is this method? Involves the speed drives. Okay. So here the current limit control means we are going to limit the current within a prescribed value or within a permissible value. So under the permissible value only we are going to control the speed of the DC drive. Okay, that is called as a current limit control. Okay, how we are obtaining that? First we will discuss with respect to the closed loop operation. So here the DC drives means we have a DC motor. Okay, so here assume there is a DC motor. Okay, so in DC motor we have a armature and field. The first one we have the armature. The armature is representing as AA. Okay, so in this closed loop operation I have considered a separately excited DC motor. Okay, therefore the field winding is separately winded, so therefore it is called a separately excited DC motor. Okay, so here we have a source, that source required for the field excitation, that is a separately excited source, that is a VF, and the current flowing through this field current is IF. Okay, so this is the setup of the DC motor, that is armature along with the field. Okay, for this armature we require the armature voltage. Okay, so that armature voltage is derived or supplied by a rectifier circuit. So that rectifier is nothing but we know the rectifier is a converter which is used to convert AC into DC. For this operation I have taken a three-phase fully controlled rectifier. I have taken because I need to control over the armature voltage. So therefore I have a three-phase fully controlled rectifier. For this fully controlled rectifier I require a three-phase supply as an input, that is a AC. So that AC will be act as an input. Okay, so then the output of this rectifier having a average output voltage, that is nothing but VDC. The output of this rectifier or converter is represent as a VDC. The VDC is nothing but the average output voltage. Okay, so this rectifier is a three-phase controlled rectifier. Therefore, the bridge circuit is constructed by using a SCR or thyristor. Okay, by connecting the 6 number of thyristor such that we can construct the three-phase control rectifier. Okay, so that control rectifier will be produce their average output voltage. So that is called as a three-phase fully controlled converter. Okay, so now this output of this controlled rectifier will be supplied to the armature of the DC motor. Okay, so therefore this VDC will be acting as a armature voltage of the DC motor. So here we have a armature voltage V plus and minus. Okay, so this is called as a VA now. Okay, clear? Okay, so what is our aim? We need to control the speed of the DC motor. Okay, how to control this DC motor? We can obtain either field control method or otherwise the armature voltage control method. So here I am considering armature voltage control method. Okay, what it means? Armature voltage control means we need to vary the armature voltage VA along with to maintain the field current as a constant. That means we need to make it this field current as maximum. Okay, by using the excitation. Okay, while field current is a constant, if you vary the armature voltage from 0 to its rated value, such that the speed of the motor is also going to vary from 0 to rated speed. Okay, therefore, from the 0 to rated voltage, rated speed can be achieved by varying the armature voltage. Okay, that is a concept. Okay, so now how to vary this armature voltage? So this armature voltage is nothing but the average voltage of the three-phase controlled rectifier. How to obtain this average output voltage? That is, the controllable voltage can be obtained by using this three-phase rectifier. How can we obtain this controllable output voltage? That is obtained by varying the firing angle of the converter. Okay, so what is the firing angle? That is, we have a thyristor circuit in the three-phase fully controlled converter. Okay, so this is a controlled device. If you vary this alpha from 0 to 90 degree, then we can obtain the variable voltage across the output. Okay, but therefore, if you vary this alpha, we can achieve the variable average output voltage such that the VA also going to be varied. Once the voltage is applied across the armature varies, the speed also going to vary from 0 to, that is a rated value. Okay, so this is the basic concept of this closed loop. Okay, but now how to vary this alpha? Okay, normally we are going to make it this variable of this firing circuit in the external circuit. Okay, but here we have controlling closed loop operation. That is, it should be, that is, the speed of the motor should be controlled automatically. Okay, how it is controlled automatically? By the nature of the closed loop operation. Okay, for that we require the feedback. Okay, so to control the firing angle of the three-phase fully controlled converter, we require a feedback control. Okay, how to achieve this feedback control? Okay, so that is, normally we have a firing circuit. That firing circuit gives a different firing angles. Okay, so that different firing angles can be achieved based on the feedback with respect to the desired speed. Okay, so now let us discuss if you want to required speed as Wm star. Okay, this is the required speed to run the motor. Okay, so this required speed will be compared with respect to the actual speed. Okay, so therefore we need a actual speed. So that actual speed is measured by a speed sensor. That speed sensor is called as tacho generator. It's called as tacho generator. Okay, so in this rotor of the DC motor, the speed can be measured by a speed sensor that is called as a tacho generator. Okay. Then the output of this tacho generator will give a equivalent electrical signal with respect to the speed of the actual motor. That is, the actual speed will be measured by this speed sensor. So that will be given to the one filter circuit. So what is the purpose of this filter circuit? Means this filter circuit will filter out the ripples available in the, that is, tacho generators. Okay, from the speed, actual speed in the signal. What are the ripples available in the signal that will be filtered out by this filter circuit. Okay, so output of this filter we are given into the reference speed. That means what the required speed we should have in the motor, that will be compared with respect to the actual speed. Okay, but this is your actual speed which is derived from your motor feedback output. Okay, so now we have a two speed. This is your required speed and this is your actual speed. If you compare these two, then we will have an error signal. So that error signal is nothing but E omega m. So that error signal will be produce a control signal for varying this firing angle. That is our main concept. Okay, so what is the error signal? This error signal will be given to one controller. So that controller is called as speed controller. It's called as speed controller. Okay, so what is the speed controller? Here I am using PI controller. Okay, the speed controller is nothing but a PI controller. So that PI controller will generate a control signal, okay, based on the time. Okay, so that control signal will be generated by the speed controller PI. Okay, so that PI controller output will be given to the firing circuit of the rectifier circuit. Okay, that is called as a VC, will be given to the firing circuit. So this firing circuit is used to generate a firing pulse according to the signal which is developed by the PI controller based on the error signal. Is it clear? Okay, if this control signal is the directly proportional to this, that is alpha. Based on this control signal, the alpha will be produced. Okay, or generated. Firing pulse will be generated. So that firing pulse is given to the 3-phase rectifier. Based on the firing pulse, the average output voltage will be developed, such that the speed of the motor is going to be vary and the controllable speed can be achieved. Okay. So now what is this PI controller? The PI controller is required for 3 important functions. Okay, now what are the 3 important functions? The first one is called as, this PI controller is used to minimize the steady state error. That is used to minimize the steady state error. What is steady state error? That is the comparative between the reference speed, that is the desired speed, and the actual speed. That is called as the speed error. Okay, so this speed error is called as steady state error, which is used to the PI controller is used to minimize the speed error, that is nearly equal to 0. That is the first thing. Okay, then second one is called as the steady state error nearly equal to 0. Okay, that is the first function. The second function is nothing but that is damping ratio of the system. Damping ratio is going to be controlled. Okay, so damping ratio of the system will be controlled by this PI controller. Okay, then the third one is used to reduce the noise which is available in the system by using integral action. Okay, so these are the 3 important parameters which will consider for the operation of the PI controller. Okay, so the main aim, we need to make it this steady state error is equal to 0. For that, the damping ratio has to be adjusted such that to make it as steady state error equal to 0. Okay, so that will be given the generated as a control pulse of the firing circuit. Okay, so this is your normal operation of the closed loop operation. So here I have a dotted line. Why I have present like this dotted line? So here, if you are controlling like this manner, okay, we need to consider the current also. So why we require to consider the current means, whenever we are operating the speed control, the armature current should not exceed the permissible values. Okay, what is the permissible value? That is the rated armature current. Okay, so the rated current has to be maintained. That is, the operation of the speed DC motor should be below the rated current. Okay, what we require the speed control of the motor with respect to armature current. Okay, so therefore we need a one control, that is called as a current control. Okay, so that current control also included with respect to this loop. Okay, how we are going to include the current loop means, now I am going to measure the armature current. I have to measure the armature current by using the current sensor. So that armature current is measured with respect to a filter circuit. Okay, so here also I am using one filter circuit. So that filter circuit is used to filter out the ripples which is available in a current. Okay, because this current is derived from the converter, Therefore, the converters always produce a ripple. Therefore, we need to reduce the ripple. We can go for the filter circuit. So that filter circuit will reduce the harmonics and the noise is available in the current signal. So that output signal is given to a one more circuit. That circuit is called as a threshold circuit. Threshold circuit. Called as a threshold circuit. So the output of the filter circuit is given to the threshold circuit. So threshold circuit is nothing but which is used to control the armature current in the prescribed level itself or maximum permissible values. Okay, so what is the control level? So here we have a armature current and the voltage. This is IA. So I have taken IA, the axis, Y axis is the voltage signal which has to be developed. Okay. But while operating with respect to this control signal, that is with respect to the speed loop alone, if the motor is running during the time, if the current exceeds their permissible, maximum permissible value, that will be stopped or that will be protected. Okay, how it is going to be protected? If there is a current, that current is nothing but Ix, the Ix is nothing but the maximum permissible current value. Okay, about if the current is lesser than this, that is maximum permissible current Ix, lesser than this maximum permissible current Is, until that time the control signal will not be produced. The control signal is 0 alone. The control signal is only 0. Okay. So control signal is 0. It will not generate any control signal. Therefore, the output of this control signal which is given to this here in this now this is VC. So if this VC equal to 0, then the current loop will not disturb the speed loop. Therefore, what are the signal generated by the speed loop, that alone is taken care of the generating the firing pulse. Okay, until that time the current signal is developed as a lesser than this maximum permissible value. Therefore, VC equal to 0. Now the control of this motor is purely depends upon the speed alone. Okay, but whenever the current exceeds the maximum permissible value, that is the Ix, immediately what will happen? This threshold circuit will produce a huge amount of this control signal VC. Okay, so even though there is a small change in the current, that is beyond this rated current, if it is a minimum value of the current itself, makes the huge amount of the, that is a output signal. So that output signal VC override the speed control, because if you are running this motor under this condition, the motor may destroy with respect to the maximum permissible current. Okay. Therefore, we need to maintain a maximum permissible current such that this threshold circuit will interact or will overact the speed loop. Now the speed loop will be terminated with respect to this signal, that is a VC. Okay, so therefore based on this VC signal, now the alpha will be generated. Alpha will be generated. So now it's overcoming the speed signal. Therefore, the maximum permissible limit will be controlled over the control signal of the firing circuits. Okay, so clear about this firing circuit is now applied to this three-phase fully controlled converter. So that will be make it as average output voltage. Therefore, the current control will control over the speed of the motor with respect to the maximum permissible value. Okay, it will be lesser than the maximum permissible value. Okay, so whenever it reaches the maximum value, that time alone the VC will be developed. So during that time, it will overcome the speed loop. Therefore, this current loop take the charge of controlling the motor. That means that changing the value of the motor speed will be attained with respect to this current parameter. Okay, so along with this rated permissible value, the speed is controlled. Okay, clear. Once again, this rated value of this current will be lesser than this, the maximum permissible value. Then again, this control value is going to be 0. Now this loop will be taking in charge with respect to the speed loop. Okay, at a time, either current loop will be control over the speed, or either speed loop will control over the speed. Okay, so at a time, both loop will not be control the speed loop. Okay, so therefore this method is also called as, this current limit control is also called as parallel current control. Parallel current control. Because it is along with the speed loop, okay, the current loop also is going to be controlled in parallel whenever the current exceeds the maximum permissible value. At the time only the current control is taking care about the speed control of the motor. Okay, clear? So, but this is called as the current limit control. Here, the current is limited with respect to the maximum permissible value. That's why it is called as a current limit control. Okay, clear? Thank you. So, now we are going to discuss about the second method. Okay, so what is the second method? The second method is nothing but inner current loop method or inner current control. Okay, so what is inner current control? What is the difference between this method, that is a current limit method, and the inner current method? We will discuss in the next one. Okay.